this is going to be our last lesson on graphing quadratics. Today we're going to learn how to graph from standard form if we can't factor. Alright, so far we know vertex form, which is our first one, standard form, which is our second one. Last lesson we talked about our intercept form, but today we want to talk about standard form again. We learned last semester that sometimes you cannot factor from standard form. Sometimes you have to use your quadratic formula to solve. It just doesn't work out. So here's an example of a quadratic that will not factor. If we try and do box and diamond, there are just no numbers that multiply to one and add to the other, so we need some alternative for graphing. Okay? The alternative for graphing is a formula. So the vertex of a quadratic occurs at negative b over 2a, comma, f of negative b over 2a. Now I know a lot of you are looking at that and you're like, wow, I don't know what that means, but it's okay. We know this formula, ax squared plus bx plus c equals 0 or equals y. This is called standard form of a quadratic.
Nielsen, please call the main office. Josh Nielsen.
This is called standard form of a quadratic. Now, from this, it's pretty easy to fill into this equation. Okay, so let's go ahead and look at our example. We see here that a is negative 1. We see that b is 4, and c is 3. So if we want to find negative b over 2a, I'm just going to take negative 4 over 2 times negative 1. If we simplify, we get 2. This is just the x value of our vertex. Okay, but the vertex occurs somewhere not necessarily on the x and y axis. So now we need to find y. So what do we do with x to find y? We just plug it in. So I'm going to take this 2, and I'm going to plug it into my equation for x. So here I'm going to say negative 1 times 2 squared plus 4 times 2 plus 3. Then if I follow order of operations, 2 squared is 4. 4 times 2 is 8. One more time, negative 1 times 4 is negative 4. And if I combine all of these, I get 7. So now I have the point like my vertex. So on my graph, I'm going to the point 2, 7, which is right here. Now from here, we are just going to use this a term, that number out front, like we did on the first day of graphing. So remember, the most important part of a quadratic is the square. So from the vertex, I'm going to go out 1. And I say 1 squared is 1. 1 times our a term of negative 1 is negative 1. So I'm going to go out 1, down 1. Same thing other side, because we know a quadratic is a U. Let's repeat. We go back to our vertex. This time we're going to go out 2. 2 squared is 4. 4 times our a value of negative 1 is negative 4. So I'm going to go out 2, down 1, 2, 3, 4. And there is my perfect U. Okay, if you think you definitely know what's going on, you can find negative b over 2a, you can plug it in, you can find y, you can use your a. Go ahead and pause the video and try this second problem. All right, let's do this problem together. Here we see that a is 2, b is negative 8, and c is 1. If we want to find negative b over 2a, we would get negative 8, which is positive 8, over 2a. So this gives us an 8 over 4, which is again a 2. Weird coincidence. Now that gives us the x value of our vertex, but we need to use that to find our y by plugging it back in. So I'm going to say y equals 2 times 2 squared minus 8 times 2 plus 1. So we get 2 squared here is 4. 8 times 2 is 16. 2 times 4 is 8. And if we simplify, we get negative 7. So this time our vertex occurs at the point 2, negative 7. So if we graph that, we have 2, negative 7 right here. Now from there, we just need to go out and over. Okay, so I'm going to go out 1. 1 squared is 1. 1 times 2 is 2. So out 1, up 2. Same thing, other side. We're going to go back to our vertex and go out 2 this time. 2 squared is 4. 4 times that a value of 2 is 8. So I'm going to go out 2, up 8. Same thing, other side. Sketch in my U. And you've got it. There are a few situations in which you might not know which method to use. So it's your responsibility to look at a quadratic and figure out how you want to graph it. Okay, so if it's in vertex form, we're just going to graph the vertex and go out and up. If it's in standard form, we're going to try and factor it and graph our x and y intercepts. And if it's in standard form and we can't factor it, we're going to use the negative b over 2a. So pause the video and try and guess which method we will use for example 1 and example 2 here. All right, example 1 is special because we only have x in one place. If we only have x in one place, we want to use vertex form. Okay, so remember, vertex form is y equals a times x minus h squared plus k. So if we look at this graph, we can see that 4 is my k value. And k tells us that it's going to go up 4. Now the reason this problem looks weird is because h is 0. We don't move right or left at all. So my vertex is just right at 4. Now from here we need to use this a value of negative 1. And we're going to go out 1 from my vertex. 1 squared is 1. 1 times negative 1 is negative 1, so we go out 1, down 1. This time we're going to go out 2. 2 squared is 4. 4 times negative 1 is 4, so we're going to go out 2, down 1, 2, 3, 4.
Will you please call the main office?
And now we have our beautiful U. All right, number 2. Number 2, this one we have x in 2 places. Okay, so let's go ahead and try to get it into factored form. Okay, factored form, first thing we do when we factor is look for a greatest common factor. Now the only thing that's common here is x. So if I factor it, I get y equals x times 1/2 x plus 3. Now that's in factored form. From there, I can set each of my factors equal to 0. So x equals 0, 1/2 x plus 3 equals 0. This one's already done. Here I'm going to subtract 3 and get x 1/2 x equals negative 3. Then to get rid of the 1/2, we just multiply by 2. And I get x equals negative 6. I can plot my two x-intercepts of 0 and negative 6. The next step is to find our y-intercept by setting x equal to 0. So I'm going to set x equal to 0 in my original problem, just in case. I'm going to write y equals 1/2 times 0 squared plus 3 times 0. Well, 0 times anything is 0. 0 times anything is 0, so I get y equals 0, which I already had. So that means I need to use my table. So for good time's sake, I'm going to pick negative 3 again because it's smack dab in the middle. And I'm going to plug it into my problem. Now you can plug it into either form, but I always go back to the original problem. So I have 1/2 times 3 squared plus 3 times negative 3. Whoops, that should be a negative 3. Okay, now order of operations, negative 3 squared is 9. Negative 3 times 3 is negative 9. And here we get 4.5 plus negative 9, giving me a negative 4.5. So I'm going to go on my graph. 2, negative 3, negative 1, 2, 3, 4.5. And beautiful U. There it is. All right, so remember today you need to be able to factor, find your x-intercepts, find your y-intercepts, make a table, and graph U's from any type of equation. Make sure to try these two problems. They will be collected tomorrow in class. The bonus question at the bottom may give you extra credit. Good luck.